Hello, welcome to Unit 5, Lesson 3. I'm Professor Blackman. In this lesson, we're going to be talking about dividing polynomials. We're going to divide a polynomial by a monomial, divide it by a binomial, and then we're going to use synthetic division to divide certain types of binomials. Here I have shown some notes on dividing fractions and how things work. This is very important for when we're talking about a monomial, which is a single-term polynomial. And so we can divide each one up. We have some notes on synthetic division right here, which will be the last thing that we talk about. So let's go ahead and get started. All right. So when dividing by a monomial, what you want to do is you want to split up that term. So we're going to split up each term, separating them by addition, and rewrite it out. And this is the easiest way to divide a polynomial by a monomial. Okay, and then 24 divided by 6 is 4. X to the 6 divided by x squared. We can use the rule a to the m divided by a to the n is equal to a to the m minus n as a general rule. And so 6 minus 2, or if there's 6 on top and 2 on bottom, 2 get canceled out. And you're left with x to the 4th. Bring down your sign. 18 divided by 6 is 3. X to the 5th divided by x squared. It cancels out 2 of them, so that's x to the 3rd. Minus 6. And then all the x squareds cancel out, and you're just left with 6. I always like to look at the pattern. So if you look at the power of 6, power of 5, power of 2, that's down 1, down 3. Now we have power of 4, power of 3, power of 0. So down 1, down 3, as just to make sure that my degree of each term is correct after dividing. All right, let's go ahead and separate out the next one. So we have 45y to the 7th divided by 5y squared minus 20y to the 4th divided by 5y squared plus 15y squared divided by 5y squared. Okay, 45 divided by 5 is 9. 7 on top, 2 on bottom. 2 cancels out. We're left with y to the 5th minus 4. Y to the 4th on top, y squared on bottom. So that's going to become y squared plus 15 divided by 5 is 3. All the y squareds cancel out. All right, let's look at some more. So now we're going to divide by a binomial. And so in order to divide by a binomial, we are going to use long division. So I'm going to put x plus 5 here, and then put x squared plus 7x plus 14. All right, so we're going to look at 81 over 7, which is something that we did in the past using long division. Or 81 is over 7, so 7 goes on the outside, 81 goes underneath, and then we put a 1 here because 1 times 7 will give us 7. After we do that, then we subtract, and then we apply that subtraction, and 8 minus 7 gives us 1. Then we bring down the next term as a 1, and then we figure out how many times 7 goes into 11. Well, that's 1. 1 times 7 gives us 7. And then we subtract again, and that gives us a remainder of 4. So this is a remainder of 4. So sometimes we write as remainder of 4, or sometimes we'd write that as plus 4 over 7. And so 11 and 4/7 is the same as 81 over 7. So now with our problem, we're going to try and figure out what is the biggest number that will eliminate our first term. Well, what we need to do is we need to multiply that first term by x. So by doing x times x plus 5, we get x squared plus 5x. And so I'm going to then write that right here as x squared plus 5x. And just like before, we are now going to subtract that. But subtracting this is because there's two terms, we need to make sure that subtraction is applied to the first term and it's applied to that second term. And so now we get x squared minus x squared cancels out. 7x minus 5x gives you 2x. We bring the next term down. And now we repeat the process again. Well, what do we need to multiply x plus 5 in order to turn it into a 2x plus something? So we need to multiply by 2. If we multiply x plus 5 by 2, we get 2x plus 10. And so I'm going to put a plus 2 here because that's what we're going to multiply by. And that will be 2x plus 10. And just like before, we will subtract that. And so as we subtract this, we also need to make sure the second term is being, that subtraction is being applied to it. And so now we end up with 2x minus 2x cancels out. That first term should always cancel out. And then 14 minus 10 gives you a 4. And we write that as a remainder 4. Or sometimes we would write that as plus 4 over, just like we put it over 7, because that was what was in the denominator. Here we're going to put it over x plus 5. All right, let's look at another example. Okay, so in this one, we're going to move our y minus 2 to the front. And underneath the bar, we're going to put our 5y cubed plus 6y squared minus 9y plus 10. Okay, so here we need to figure out what do I need to multiply y by in order to turn it into 5y cubed. So I'm going to use 5y squared times y minus 2. And that will give me 5y to the third minus 10y squared. Okay, so I'm going to put my 5y squared up here on top. And then underneath, I'm going to put my 5y to the third that I multiplied out on the other screen minus 10y squared. Then I need to subtract that. So subtracting here makes this positive. So the signs over here were positive, negative. Well, over here now we have negative, positive. So the signs should always be opposites of each other. First term cancels out, then we get 16y squared. We'll bring down the next term, minus 9y. Okay, now I need to multiply by 16y. I'm going to multiply that by my y minus 2, and that gives me 16y squared minus 32y. 16y squared minus 32y. And what I multiplied by was that 16y. Okay, now I need to subtract that. So make that negative, make that positive. I like to circle it to make sure I remember that I did it. And so now I do 32 minus 9, which gives me 23y. Bring down my next term, which is the plus 10. So what do I need to multiply y minus 2 by in order to turn it into 23y? Well, that would just be the number 23. So I'm going to put my 23 that I need to multiply by. And that will give me 23y minus 46. So I'm going to put that under here and do my 23y minus 46. And then I need to subtract that, which changes the sign. Positive, negative is now negative, positive. First term cancels out, and when you add that together, you get 56. So this is my remainder, or we can write it as plus 56 over y minus 2. All right, let's look at another example. All right, so this one's a little bit different because it's now x squared plus 2. But what I like to do is put a placeholder so I remember that a term was skipped, the x term was skipped. Okay, underneath the fraction bar, I'm going to put the 2x to the fourth minus x to the third minus 5x squared plus x minus 6. I would do the same thing if one of these powers were skipped, but since all of them are there, 4, 3, 2, 1, and the power of 0, I can leave it like that. Now I need to figure out what I need to turn an x squared into 2x to the fourth. So I have my x squared plus 2 over here. And I need to multiply it by a 2x squared. Okay, that will give me a 2x to the fourth plus 4x squared. Now again, there's that placeholder right here of 0x to the third. Now that's important because when I'm lining my terms up, my 2x to the fourth is going to go here. 0x to the third is going to be skipped, and my plus 4x squared will go here. And now I subtract that. Subtract. And I bring down everything. So first term cancels out. I'm going to bring this negative x to the third down. Negative 5 and negative 4 give me negative 9x squared. And I'm also going to bring down this x. So what do I need to multiply to get a negative x to the third? Well, that's a negative x. Is what I'm going to multiply my x squared plus 2 by. So that will give me negative x to the third minus 2x. So my negative x to the third goes there. I'm skipping the middle term, my minus 2x. When I go to subtract that, negative now is positive. Now is positive. Okay. Don't forget to write what you are using at the top. First term cancels out. Negative 9x squared. X and 2x gives you 3x. And then I'm going to bring down my next term, which is the minus 6. Okay. What do I need to turn x squared into negative 9x squared? Well, that's a negative 9. X squared plus 2. Negative 9x squared minus 18. So I used a negative 9 at top. And so negative 9x squared minus 18. And when I subtract that, this is now positive. This is now positive. And I get a first term canceling out, and I get 3x. 18 minus 6 is a positive 12. So I get plus 3x plus 12 over x squared plus 2. Let's look at our next example. All right, so here we're going to use synthetic division. Well, in synthetic division, we are told this very important x minus a. So we need to identify a. So if it's x minus 2, like in our current example, then a equals 2. If it happened to be x plus 2, well, then we would rewrite that as x minus a negative 2, which would then identify our a as negative 2. So when you're given the x minus a, whatever is given is since it says minus 2, the a is our 2. So now let's set up our synthetic division. Synthetic division is what the word synthetic means. It's fake division. It is a faster way to do division. So we're going to take this a of 2, so we identified a as 2, and we're going to put it over here in a little box. And then we're going to take the coefficients of each term. 3, 2, 1, 0. Nope, no degrees are skipped. Coefficient of 1, coefficient of negative 7, coefficient of negative 13, and a coefficient or constant of 3. And then what we do is we drop the first number and we get a 1. Then what we do is we multiply these two numbers and we put it in the next spot. So 2 times 1 is 2. Then we combine we combine these numbers. -7 and 2 give you a -5. And then you multiply again. 2 times -5 is -10. Combine these two numbers and you get -23. Multiply again and you get -46. Combine and you get -43. So what now we can do is when we started, this was an x to the third. After we divide, this becomes an x squared. So we can write our answer now. This equals x squared minus 5x minus 23 with a remainder of -43 over what you divided by, x minus 2. So let's look at another example. All right, so 3, 2, 1, 0. So we have a power that's skipped. So identify your a. In this case is -2. We're going to put that over here in our box. Power of 3, power of 2, power of 1 is skipped. So right here, there's an understood 0 to the x. So I'm going to write 1, -2, 0, 8. Drop my first term, which is 1. And then multiply again, gives you -2. Add gives you -4. Multiply gives you multiply -2 and -4, you get 8. Add those together and you get 8. Multiply times -2, you get -16. Add, you get -8. And so when we after we have applied the division, we start with x to the third. So this is now an x squared minus 4x plus 8 plus a -8 over what we divided by, which was x plus 2. All right, let's look at our final example. Okay, so if you notice, we have y to the fourth, and we go straight to a constant. So there's a 0y to the third, there's a 0y squared, and there's a 0y. That all is being skipped. So when we take our y minus 2, so that identifies our a as 2, we put that 2 in our box, and then we go 1, 0, 0, 0, -16. Make sure you're including all powers and none are skipped. All right, so start out like we did before. Multiply by 2, we get a 2. Combine, you get a 2. Multiply, you get a 4. Combine, you get a 4. Multiply by 2, you get an 8. Combine, you get an 8. 2 times 8 gives you 16. Combine, you get a 0. So no remainder here. When we apply that division of this that's given, it becomes y to the third, because we go from power 4 to power 3, plus 2y squared plus 4y plus 8. And that's how we apply synthetic division. That's all I have for you today. Happy study.